Hello, good morning, everyone. Good morning and welcome. Can you hear me and see me? Okay.
Yes.
Yeah.
Yes.
Okay. Good morning and welcome to our APSCE webinar. And first, I want to express my apologies for last week's technical problem. Feel very sorry about that because we can I and our Alex from FC couldn't log in the Zoom last week, so we extend this webinar to this week. So thank you for your understanding. So thank you for joining us today for FC webinar number 59. And my name is Bo Jiang from East China Normal University. And I'm very honored to be your chair for this session. We are very excited to explore today's topic, effect of instructor manual feedback and ChatGPT intelligent feedback on collaborative program. And that's a subject that is highly relevant in our field right now. And we are honored to have our esteemed speaker, Professor Ouyang Fan. You can call her Ouyang or Fan from Zhejiang University with us today to share her insight on this topic. Before this talk begins, let me introduce the Professor Ouyang. Professor Ouyang is a research professor in educational technology, and Zhejiang University of China is also a top 3 university in China. She graduated from the Learning Technology Program, the Department of Curriculum and Instruction at the University of Minnesota. Her current research primarily centered at computer-supported collaborative learning, CSCL, learning analytics, and educational data mining, and AIED. Ouyang has published over maybe 30 articles in top journals in the area of education technology, such as BJET, International Higher Education, and she also has worked as a PI in several National Science Foundation projects in online collaborative learning in China. So we can see that Ouyang is a leading expert in this area, and we are looking forward to have a very informative presentation. Let's get started, Ouyang.
Thank you, Professor Zhang Bo, for the very nice introduction of me. And now I'm going to share my slides very quickly.
So if any questions, please leave your question in the QA or in the chat. And after the talk, we have 10 or 15 minutes to have a communication. Let's get started, Ouyang.
Thank you for your chair, Professor Zhang Bo. And can you see the slides and hear me well?
Yes.
Okay. Today we will have a talk on the comparison of teacher feedback and GPT feedback on collaborative programming. And before we get into the detail of the presentation, let me quickly introduce my research interests. Our team and I have 3 directions, and the first direction is CCL, and the second direction is learning analytics, and the third direction is today's talk on AI for education. And particularly for the AI for education part, we have published 3 subfield of the work for the AIED systematic review. We have some work on the AI tools in CCL systematic review, as well as in STEM education and on online education. And for the second part, for the integration of AI and LA, we have published some work to use this new approach to examine the collaborative programming, as well as some other work. And today's work will focus on the third part, which is the AI system design and education applications. So let's get into the details of today's talk. We will have 5 parts. Introduction is the first part. So AGI is artificial intelligence system that process human-like cognitive abilities. And for AGI part, nowadays in the past 5 years, we usually use GPT as a preliminary part. So GPT has been used in previous teach and learning process, such as computer programming, which is the central part of today's talk. So for the GPT in programming, we can learn from previous studies that programming is a very complicated process for students, and the students usually have some difficulty in the complicated thinking process in writing codes, debugging. So in this phase, we can say that ChatGPT can work in the programming process to provide students with instant hints. But in the real process, students usually have some difficulties to improve their computational thinking and programming motivations. Previous work has shows that ChatGPT has potentials to improve those skills. And the second part is literature review. For this part, we will have 3 parts. First, we can say that ChatGPT has potentials to work as an assessment tool in programming. From the teacher side, we can say that as a teacher, it's very time consuming for us to read students' codes and provide assessment to students immediately. Usually the teacher's feedback was provided in a delayed way. And from the student's part, they usually need immediate feedback from the teacher, because when the programming, they need to make some code change. And also sometimes they need some additional learning resources. So in this case, ChatGPT can provide students with personalized learning process. For example, ChatGPT has primary 3 functions, which is providing students with immediate feedback, as well as provide students with clear explanations of their codes. And for the third part, sometimes ChatGPT can assisting students and provide them with some examples. All of these 3 parts are very important for students' programming process and for the teachers to improve their programming. Second, we can say that from previous empirical studies, ChatGPT has provided some positive support for students' programming process. For example, Feng in 2023 reported that ChatGPT can be used in more than 10 programming languages. And Finney in 2022 used OpenAI code to test the programming, and it shows the studies empirically shows that OpenAI code scored better on programming than the students. And the question in 2023 also used ChatGPT and to compare it with the students' programming process. And also the empirical research has shown that ChatGPT has better programming performance than students. So these are works in the before like 3 to 4 years. But recently, in the last 2 years, we can see some divergence in impact of GPT on programming. For example, Coursera in 2024 showed that GPT did not lead to the programming improvement, and in the ChatGPT use process, the students' cognitive engagement decreased. And also, another study, which is performed by Liao in 2024, shows that ChatGPT sometimes hinders students' higher order skill. And also in 2025 and 2024, some other studies also show that there are negative results reported by the comparison study. So this study want to verify if there is positive or negative results of the two types of feedback. And the second part for this direction is that usually for the teachers, if you teach programming in the school, you can learn, or you can see that it's very difficult and very time consuming for instructor to collect the data and from the students, and also after the collect data, they need to provide feedback to students. In this process, it usually takes students like 1 week or 2 weeks to provide feedback. And sometimes during the process, students might need some immediate hints from the teacher. So under this case, we can say that ChatGPT can be used to complement the feedback from the teacher. So this study also want to compare the effects of these two types of feedback. This is the second aim. And the third part is that we can say that we use in the previous studies, we usually use traditional approach to analyze programming, such as interview or some other students data, or usually we use the students' final test or products from the programming as used for the that data to analyze students' performance. But LA approach can be used to connect and analyze process data during the programming process. Particularly for the collaborative programming, it can be used to reveal the collaborative characteristics of programming. And also, in particularly, it can provide cognitive, regulative, social emotional engagement from the students' programming process. So this study wants to use the integrated method, which combines the traditional and the new approach to analyze the collaborative programming process. Let's get into the third part of research methods. So all research questions, there are 3 parts. The first research question is to compare these 2 types of feedback on students' final performance. And the second question is to compare the 2 types of feedback on students' procedural engagement. And the third part, we will have students to self-reported their perceptions about their collaborative programming process. So our research context is engineering class in China, and we have 8 weeks, and the participants are 55 graduate students. For this collaborative programming parts, we grouped students into 27 groups. We have 2 to 3 students per group. And for the research design, it lasted from week 3 to week 7. So we have students have 5 weeks to programming and to finish a collaborative programming work. As we can see that we have 14 groups under the control condition, under the control group, and we have 13 groups under the GGPT group. For the two types of feedback, for the control group, we have the teacher to provide traditionally test-based feedback to students. And for the ChatGPT condition, we have the research team to use ChatGPT to generate the feedback. And we use video to create and deliver the feedback to students with teacher on the right side, as we can see from the screenshot. We deliver ChatGPT feedback in this way is to maintain a standard process as similar format for the teacher's part, then which we can compare it with the teacher's parts. The third part of this section is data collection. So we have three types of data. The first data is performance data. For the performance data, we have knowledge test, and we also have the group level products. So for the two conditions, right, we use t-test to compare the comparison of the two conditions regarding the student final performance. And the second, we have process data. So we also have two types of process data. The first process data is recording data for the students' the discourse talk. And then we use content analysis to code this data and use ONA to show the network plots for the student's procedure. And the other type of process data is computer screen data. So for the computer screen data, we use clickstream analysis, CSA, to analyze students' screen, and use ENA to analyze its procedural engagement. The final data type is self-reported data. So we use these types of data to analyze students' perceptions about their collaborative programming process. So this is the data and the analysis procedure. Next, let's get into the details of the procedural data of the codes, because it's very important for the explanation of this work. We have three dimensions of the process data: cognition, regulation, behavior. So for the cognition part, we have programming exploration, programming elaboration. The difference between these two is that for the first exploration code, students did not make detailed descriptions of the code they programmed. And for the elaboration part, students in the group make some descriptions of the code they program. And the third and the fourth is ask a question and answer a question. And the last code is peer perspective expansion. In this, for this code, students express their agreement or disagreement to the peers in the group. So these 5 codes show students' cognitive engagement during the process. And the second dimension is regulation. Depends on the data. We have 2 codes in the regulation dimension, which is understand the task and the planning, as well as reflection for the second code. For the behavioral code, we use the behavioral dimension to analyze student computer screen recording data. It has the viewing data code, searching for help, writing codes, writing annotation, running codes, view results, geographic and parameters adjustment. We have this behavioral codes. So this is the research analysis framework. First, let's get into the most important parts of the results. Let me recall we have 3 questions, and the first question is to compare the differences between the 2 types of feedback on students' final performance. Interestingly, we can see that for the post-course results, there is no significant difference between these 2 conditions. In the table, we can see that for the details, both for the knowledge test and for the programming products, the ChatGPT condition has higher scores than the control condition. So this is the results of the first question. And the second one is about the procedural engagement. Interestingly, we can see from the table, there was only one significant difference between the 2 conditions, which in the control condition, students has more cognition engagement of programming explorations than the ChatGPT group. And in the all of the other codes, including the cognition, regulation, behavior, all of those 3 dimensions, all of the codes, the other codes do not have significant difference on the other codes between under the 2 conditions. So this is the first part of the second question. And then we use ONA to show the details of students' procedural engagement. As we can see from the ONA plot, the left part in the red circle is the control group, and the purple circle on the right side of the plot is the GPT group. Overall, we can see that the control group engaged more frequently with cognitive engagement, and the GPT group engaged more frequently with regulation talk, and as well as some programming behaviors. And in the detail, we can see that in the control group, it has frequent self transitions of programming exploration, which is that students talk with their partners about the programming code without description. And in the control group, it also has closed loop transition from the programming exploration to searching for help, to writing code and get back to the programming exploration. This is a closed loop for the control group. And for the GPT group, we can see that students has very frequent self transitions of a behavior of drawing graphic frame. And the transition, there's no closed loop transition. There are transitions of reflection to write code, and from write code to understanding the task and planning the goal, as well as draw graphic frame to view results. So from the ONA plot, from this graph, we can see that the 2 groups have very different procedural engagement. And finally, for the research question 2, we conducted ENA results to show the evolutionary trends. As we recall that in the previous part, I mentioned that the programming task lasted from week 3 to week 7. So they have 5 tasks, task 1 to task 5. So we use the ENA plot to show the evolutionary change of the centroids for each week. On the lower half of the plot, we can see the red circle of the control group. And for the upper half of the network plot, we can see the purple circle of the ChatGPT group. And from the light color to the deep color is from task 1 to task 5. So we can show the change of the centroid. The results show that for the control group, it demonstrated a cognition collaborative programming process, and the students from task 1 to task 5 gradually move to the right part of the plot. Right, the right part represents the behavioral space. So students gradually moved to behaviors with a reduced cognitive engagement from task 1 to task 5 under the control group. And under the ChatGPT group, we can say that students demonstrate a regulation collaborative programming process. And the student has a large span from week 3 to week 7. As we can see from the change of the red square, students constantly for the purple square, students constantly focus on the regulation talk between the group peers, along with some behaviors moved towards the right parts of the behavioral space. So the ENA results can show as a complementary for the previous ONA results to show the evolutionary change of students' ENA centroids and their change from task 1 to task 5 after the two types of feedback. So this is the answer for results for the research question 2. For research question 3, we have a question to ask students about their perceptions of the collaborative programming process. Interestingly, we can see from the results that ChatGPT intelligent feedback was perceived by students as having more strengths as well as weaknesses. For example, for the last theme of in-process feedback, there are there were 9 students in the ChatGPT group reported that the ChatGPT provided with in-process feedback to them. Also, for the strength of the ChatGPT, it also has more students, for example, in contributing to the code improvement in the ChatGPT group, there are 14 students reported that ChatGPT contribute to the code improvement, but only 8 students in the control group reported this thing. So our research results have 3 parts. Let's have an overview of the part. For the students' final performance in terms of students' knowledge test as well as the group products, there's no significant differences found in these 2 types of final performance between the 2 groups, 2 conditions. And for the second part, students' procedural engagement, for the teacher's feedback group, it encourages students for the cognition, collaborative conversation between students. And as the task going on, the students moved to programming behaviors gradually. And for the ChatGPT condition, ChatGPT facilitated and increased the students' regulation talk among the group. And the third part, as we just talked about, shows that the ChatGPT was perceived by students as having both more strengths as well as weakness. So possible reason is that first, ChatGPT made some misleading information to students, and ChatGPT also is unable or very hard for students to solve some complicated task. And another reason for the studies that we use both feedback showed in a it's not in a real-time interaction with the students. So under this case, we can say that ChatGPT did not show significant advantages than the traditional feedback from the teacher. So for the implication part, we suggest instructors to, in the future, to pay more attention to the misleading information created by AI, and we encourage teachers to use provided scaffold AI use rather than in this study we use a long scaffold AI use. And also, AGI system can be used as a supportive tool to improve students' programming, rather than like in this work, we use it as an independent tool for the for the other groups. Limitation of this work we just talked about. First is used in interactive way, and the student did not have direct interaction with GPT. Also, the teacher used the on-scaffold use of AI. Future study, we should explore the use of LLM model for created automatic feedback to and also improve the accuracy of the feedback. So in terms of this limitation, recently our team has two other works, which is I want to introduce very quickly in today's presentation. The first one is we designed and implemented a generative AI-driven conversational agents. And the second work, we use LLM-powered system to facilitate collaborative CQC process. So the final part of today's talk, we will get into some details of this two recent work. In the first work, we designed a AI tool online. It's an online platform called Agile Copilot, which is developed by GPT-4. And in the platform, we can see from the screenshots, the teacher can upload teaching and learning content into the platform, and then the conversational agents can provide the students with some hints and information in terms of based on the course content. And then we use a quiz experimental study to compare two phases. The control phases is the first 4 weeks of the class, which we didn't use the platform. And in the last 4 weeks, from week 5 to week 8 of the class, we use the Agile Copilot platform to support students' inquiry process. So quickly, we have our results and findings shows that students in the platform phase, which is week 5 to week 8, engaged more in the inquiry process than the control phase. And also, which is we didn't want to say is that the student in the last 4 weeks had increased copy and pasting, and also a decrease in the depth of text in the process. But in the experimental phase, students performed better on the study sheet part, and their performance on the test declined compared to the first 4 phases, which is also we did not want to say the part. And for the self-reported perceptions, students showed some positive perceptions about the online platform. This is a quick overview of the results of the first study. The first study, which is now is under review. Under review for like 2 or 3 rounds. The second study is a Chinese paper, which I believe will be published very soon, like in 1 month. We designed a multi-agent system for the argumentational collaborative knowledge construction, work. And this online platform, we call it APSCE AI. It can provide adaptive support for students' participation, cognition, argumentation, and the social dimensions when they have online collaborations on the work. And quiz experimental studies also used for this work. We have 7 control groups without APSCE AI support, and we have 8 groups with APSCE support. As we can see from the screenshot, it's online discussion process, and the agent can provide students with their their participation and some other dimensions engagement from this tool. So the findings, we let's quickly introduce the findings. In the experimental group with the tool support has higher test score than the control group. And for the group products, it also has higher score in the AI support group. And compared to the control group, the AI tool support group had more great cognitive engagement. DNA plots are also used in this study to show the connections of the cognitive codes. This is a quick overview of these 2 studies. So after the introduction of three work we have done in the past 2 years, what's the future of using AI tool in education? I cited a keynote talk from Dragon. He mentioned that if we want to improve education in the future under the AI support, students or people should have high human skills as well as AI empowered skills. And the final goal for us is to improve, increase, and empower students with both dimensions, right? Both the human dimension skills as well as the AI empowered skills. So he mentioned 3 takeaways, which is also reported, and we can summarize from the previous studies our team has worked. The first one he spoke is that no free lunch for adaptive learners. So it's very difficult to develop combined human and AI empowered skills. As we can see from the previous studies, in the GPT group, students has more regulation engagement to analyze if the GPT give the right answer or the wrong hint, right? So if we want to improve student skills, we have to combine those 2 types of skills from the students. Also, students should have human skills first. If students did not have a critical thinking skill set, he or she might take the feedback immediately and might have a wrong programming process. The second key takeaway is he reported is that lazy mental cognition may emerge with unscaffolded use of GAI. This is also a takeaway point I mentioned before. With unscaffolded use of generative AI, it might sometimes and usually in our cases, frequently created some inaccurate information for students. So under these circumstances, students need to use a very higher order skill of mental cognition to think about how to use the information provided by AI and how to integrate the information. created by AI with his or her work. And the third key takeaway from Dragon is that longitudinal studies are needed to combine the teacher scaffolds with AI support. And as we can see that the previous 3 studies, we only lasted for 8 weeks for each study, which is very short. And from the very short periods of the study, the student might just get into familiar with the AI tool and for 3 or 4 weeks it ends. So in the future, we hope that we can see more studies that take a longer time to test the AI tool support for students' teaching and learning process. Okay, thank you all for your attention for today's presentation. And we will have some time to answer your questions from the chat section of the tool. If you are interested in my work, please feel free to add my WeChat from the QR code. Thank you, Professor Jiang Bo.
Okay, thank you, Ouyang, for the fantastic presentation about the ChatGPT on programming. And I see Professor Ouyang showed us a very great empirical study to explore the difference between the human feedback and the AI feedback. Also, the experiment results shows that there's no significant difference between the program performance, I think is a program score, between the two groups, but it find the results shows the significant difference between the program behavior and cognitions, and in the two groups. Also, Professor Ouyang also introduced two related works after this study. I'm very impressed by the Edu Copilot. She designed to help students to learn programming. So I'm also very like the Jorgen's key three key points that the scaffold. I strongly agree that scaffolding is different with AI support. AI support is for workspace, and scaffolding is for learning. So it's really needs some longitudinal study to explore how to combine the scaffold with AI support in the learning senior. So thank you, Ouyang. And we now have some time for questions. I saw some questions have raised in the chat. The first question. Okay, let me see. Let me read the question. Chen Xin Li raised the question, but she said the question is has been answered by the APSCE AI. So the first question is proposed by Xue Yin. She said, or he said, thank you for your talk. I have one question about the feedback process in your collaborative program study. Was the feedback given to individual students or to the group as a whole? And in each group, did students ask their own questions, or did they select one to represent the group?
Okay, I see the question on the screen.
Okay.
It's about the first work, right? In and ask was the feedback
Yes.
given to individual? It's given to the group as a whole. The feedback
Okay.
is given to the group because it's a collaborative programming process. So the group work as a whole group. And the knowledge test is to test the individual students, but the group level product it was done by the group as a whole. And in each group, did students ask their own question or did they select one to represent the group. Also for the GPT conditions, we take the students' code and we input student groups codes into the platform, and then GPT will give students some hints about the programming codes we inputted into it. So students did not have direct interaction with GPT. So it's not conducted in the traditional way, such as we have the GPT for students to use. As we can say in China, it's conducted in previous, like 3 years ago. In China's classroom, we cannot use GPT directly. So this is the answer for the question from Yin Chue.
Okay, thank you. Thank you, Ouyang. May I follow the interest question? I have a question. How students use ChatGPT in this course? They use the ChatGPT in the classroom, within the classroom teaching, or in the homework or some project?
Okay, so for the collaborative programming, it's a project. It's a project for the students to work for 5 weeks, and the students have 13 to 14 minutes in classroom to
In
work
classroom.
together to solve the programming process, to conduct the programming process, and also because it's a real class, right? Students will have some time after class to improve the codes.
Okay. Okay, thank you. The second question from Andy Hu. Professor Ouyang, thanks for your thought-provoking talk. I'd like to know you mentioned insignificant result in study one. Where's the question? Okay, and even declined performance in study two
Yes.
when used generative AI. So you verified the generative AI is negative.
This is yes. It's not. We cannot say that it's very complicated because for the educational technology field, we usually get these questions about if you use very advanced technology or tool in your teaching and learning process. But maybe in empirical research, some research might reported it improves student performance. But yes, in our study for the final performance part, because besides the final performance, we also have some impact on students' procedure, right? So student process assessment is also a very important part for our field. So in study one, for significant results parts, it not have significant difference between two conditions, but for the detailed score of the students, we can see that in the experimental condition, it has higher scores in compared to the other condition. And for the second study, only for the performance it declined, but in other parts, for example, for the procedure, we can see that in the GPT condition or AI2 condition, students might have more engagement in their cognition part, right? So it's also, in addition to the final performance, learning scientists usually very focus or take the process assessment very important point. So I think that both the performance as well as the process is important. Also, another point for this question is that we want to say in the field in the future to use the AI tool in a longer periods and maybe in 1 year or 2 year also to test if it has the same performance as we used in the short periods. So that is a future trend of our field study.
Okay, thank you. Thank you, Will. Any other questions? If you have any questions, please write your questions in the chat. Professor Ouyang, I have a question about the behavior of the students in the two groups. I remember in one of your slides, you said you collect some students program behavior data, such as writing code, writing code behavior. I want to know whether you collect some students tinker behavior. Tinker means students repair their code. You know, here when we start program, we need to repair our data, debug our data, repair the code very frequently to show some grammar errors or some errors. So
Debugging, right?
debugging, yeah. So
Debugging.
the tinker behavior is very important, especially for the for the newcomer. So did you find some significant difference between the build program behavior between the two groups, especially in the writing code
Mm.
behavior? Yeah. Did you find
Yes,
any?
I think it's very important because for programmers, debugging is a very important part for our programming process. And for the question, we can say for the frequency of the codes, there is no difference, no
No difference.
significant between these two conditions for the behavioral code. And also, debugging is an important behavior for programming. But in this class, it is use MATLAB to code and create some graphs. So it's not a traditional programming like C or C++ programming process. So we did not use the debugging code to code the procedure and the adjust the parameter like the final one. The final one under the behavior dimension is like the debugging process.
Mhm. Okay, thank you. There are also another question from the chat, Xiaoyin Zhen. The question is based on the question brought up just now. I was wondering, are there any specific structures of feedback provided by GPT or instructor? Are they only hint-like feedback? What? Where's the problem? Oh, a lot of questions. Xiaoyin Zhen.
Okay, based on the question, I would wonder, are there any specific structure of the feedback provided by? Yes, there are a specific structure with 5 dimensions of the feedback. Let's see. It's here. So we have 5 dimensions of the feedback, which is correctness, readability, efficiency, maintainability, compliance. We have these 2 dimensions to report the feedback to the students. And the other one, how to get back to the chat? How to get back to the chart? Yeah. Very long. Second, the student feedback literacy may impact. Yes, the student feedback literacy is also a very a key point for the study, but we did not test this part in our study. I think it's a good direction for future study to integrate or to include the literacy part. Andy Hu, what plan for the team used to develop the tool? Oh, the AI, which one? The second one, right? The third one we use LLM to develop the CKC AI tool, and the second one we collaborated with AI company. I think it's the platform is Java or also. I need to check. We collaborated with a company, and the tool was completely developed by the company.
Okay, let me read another questions.
Yeah.
If from Mr. Liang, if correlated your studies to teaching in primary or secondary student learning STEM, will you foresee any significance? That's
Yes,
good.
STEM education is also a field that we usually use a AI tool to support students' learning process. Mm, as as I know that AI use in at least in China's school, it's not used in the formal in-class teaching process. Maybe students can use AI tool or platform in the informal learning process, right?
Okay. Okay, my
I don't think that significant difference is good. I don't think that is good.
yes, that's great answer. Okay, our last questions. Uh, I'd like to ask how the ONA method is explained. Is based on
Okay.
R? Yeah,
Python and R.
in
Python.
Python.
I suggest you use Python, yes.
What's the
And
difference between ONA and ENA? Oh,
ONA is directed. In the ONA plot, you can see a, a direction way from one code to another code. But in ENA, there's no direction from one code to another code, just the connection significance between two codes. Difference is this.
okay.
It's under the same analysis approach from the same team.
Okay. Thank you, Ouyang. Please stop sharing your screen, Ouyang. And
Yes, sure. No,
okay.
no problem. For
And
learning, for learning. Only for learning. Okay, no problem. I can share it with Professor Zhang Bo, and he will have some channel to maybe to share the slides with you guys. I'm not very sure the working process.
okay,
Or,
thank you, Ouyang.
mm.
Ouyang, please stop sharing your screen.
Okay.
Okay. Okay. And I need to share my screen. Okay. Thank you. Thank you, Ouyang, for your great presentation. Also, thank you for all your questions. And we are out of time for today's Q&A. And I want to extend another huge thank you to Professor Ouyang for your truly insightful presentation. And as you see in the screen, there is a QR code. If you have any feedback, your feedback is very important. If you have any feedback about this seminar or about APSCE webinar series, please submit your feedback by scanning the QR code. Thank you so much. And a final thank you to all to Professor Ouyang and our audience for your time and excellent participation. The session is now over. Thank you again and have a good day. Bye, Professor Ouyang.
Thank
Thank
you
you.
all. Thank you all for your attention. Thank you, Professor
Thank you.
Jiang Bo.
Bye.
See you later. Bye bye.
See you. See you.